Segment 25, Brightness and Magnitudes. This is a very brief segment covering the magnitude scale that's used by astronomers for describing the brightness of stars. This system dates back to the time of the Greeks. Hipparchus, who made the first great star catalog, shown here in a Greek stamp from the pre-Euro days of Greek postage, and listed the magnitudes of those stars in a system that's very similar to the one that we use today, 2,000 years later. Astronomers divided stars into 5 classes. These stars are the first, second, third, fourth, and fifth magnitude. As it turns out, when we have quantitative means of measuring, first magnitude stars are about 2.5 times brighter than second magnitude stars, and second magnitude stars are about 2.5 times brighter than third magnitude stars. Note that larger magnitudes means fainter, so each step in magnitude is then 2.5 times fainter than the one before. The actual difference is a factor of 2.512. So stars with a magnitude difference of 0 have an intensity ratio of 1. Stars with a magnitude difference of 1 have an intensity ratio of 2.5. With 2, it's a factor of 6.3. Something to remember is that stars with 2.5 magnitudes difference are 10 times, a factor of 10 difference in intensity. Stars with a 5 magnitude difference are a factor of 100 different in intensity. The formula that you can use to derive the magnitude difference from the intensity is that the magnitude of star A minus the magnitude of star B is equal to 2.5 times the logarithm of the ratio of the intensities. So for example, if I have two stars that are where star A is 100 times brighter than star B, then I have a log of intensity ratio of log of 100, which is 2, and 2.5 times 2 is 5. So why do we measure apparent brightness in this way? The reason is that our eye, in order to be sensitive to things in bright sunlight, to be able to see the sun, in fact, and to be able to see the glowing eyes of the beast that's about to eat you on a dark night, you have to be able to work over an incredibly large dynamic range. And your perception system does this by looking at things in a more or less logarithmic way, which is optimal for dynamic range, if not for precise measurements of intensities. This is kind of what the sky looks like. The sun has an absolute apparent magnitude of about minus 27. The full moon about minus 12. Venus, at its brightest, is about minus 4. The very brightest star, Sirius, is about minus 1. And with your unaided eye, here called the naked eye, the faintest things you can see on a very dark night are about 6th magnitude. The Hubble Space Telescope, on the other hand, can see to about 28th magnitude. So from 6th magnitude to 28th magnitude is about 22 magnitudes. So 20 magnitudes would be 4 factors of 100. That's 100 million, and then another factor of 6.2, so about 600 million times fainter than what you can see with the unaided eye. Pretty amazing. Before you take the quiz, practice a bit with your calculator. This quiz will have some numerical problems on it. A source that is 100 times brighter than a 10th magnitude source will be 5th magnitude. A source that is 2.5 times fainter than a 21st magnitude source will be 22nd magnitude. If you play with these numbers, you should be able to work out the things we're asking about.